Today, I'm designing a new version of my finger jointed box model that combines some attributes of my previous models and also fixes some problems that I was having with those models. Keep in mind that I'm building this model specifically to be used for designs that are cut on a laser cutter, and some of these techniques and the ordering of the operations that I use are because of that requirement. If I were building a solid body for milling on a CNC or for designing architectural models, I would build this model differently. And if I didn't need the box to be parametric, I could easily simplify certain portions of the model. Because the techniques I'm using here are very similar to my previous videos, I'm not going to spend a lot of time describing the purpose of individual steps, but I will walk through enough that you can recreate the model if you're familiar with my other videos. If needed, I recommend going back to watch my consistent with finger jointed box video. Before starting with the model, I'm going to define the parameters that I want to use to drive the model's dimensions and features. I'm going to start with the length, width, height, and thickness parameters, using similar values from my previous videos. In this model, however, I am also going to define 3 additional parameters that I can use to calculate the inner dimensions of the box. In this base model, I'm only going to be using the inner height, but having the inner width and length available for future modifications will be beneficial. I'll start with the ciheight parameter, which will be the height of the box minus the thickness of the bottom panel, and then the cihwidth parameter will be the width of the box minus the thickness of the front and back walls, and the ciheight will be the length minus the thickness of the walls on either side. I'm using the letter C at the front of these parameter names to remind myself that these are calculated parameters that I should never change. Next, I will define a finger width parameter similar to my previous models, but in this case, I'm only using the finger width parameter as a target value for the finger width so that I can keep fingers as close to the same size as possible, but I'm not going to be dependent on them being the same size. This parameter will also be used for calculating the number of fingers that I want on any given edge. To calculate the number of fingers, I'm going to use a couple of rounding functions. First, dividing the length by the optimal finger width that I just defined, rounding that number up to the nearest whole number, dividing again by 2, and then rounding down the result to the nearest whole number. Then I multiply by 2 again and subtract 1. This will estimate the number of fingers that should exist along the edge, but it will round that number to the nearest even value. 2, 4, and 5 get rounded to 4, and so on and so on. But then because I want to make sure that I have an odd number of fingers on any joint, that I subtract 1 from that even numbered value. In addition, I want to make sure that I always have a minimum of 3 fingers across a jointed edge. 1 finger on one panel and 2 on the other, and that will be the minimum that I will accept on any given edge. With the target finger width and the number of fingers calculated, I also need a parameter which I will call hfingerw to calculate the actual width of the fingers along this edge. Essentially, I want this model to size all fingers as close as possible to my optimal finger width, but size them bigger or smaller as the dimensions are changed. This is especially important for very large fingers in smaller boxes to make sure that I have at least the 3 fingers along each edge. To make some calculations easy in the future, I'm also going to define a parameter for the number of notches that I'm going to cut along the length edge here, and I'm going to calculate that number, which I will call L notches, by dividing the total number of fingers by 2, and then rounding down that value to the nearest whole number. So the number of notches that I cut along an edge will always be one less than the number of tabs along that edge. The last parameter I need for this axis is for the length of the reference line that I will be using to position the notches that are cut into the bottom panel. Once these parameters are defined for the length, I need to replicate the same parameters for the width and height. One key difference in this model when calculating the fingers for the height axis is that I am going to use the inner height for calculating the number of fingers because of the fact that I don't want a finger to overlap with the bottom panel. I want to remove the thickness of the bottom panel from the calculated length that I'm using to calculate the fingers. With the parameters defined, before going any further, I will save the file and call it finger jointed tray. And because I'm using this model for the basis of other projects, I'm going to create a new component and make sure it is active, and then build my model in this subcomponent. With my previous boxes, as I was using them in other projects, I realized that having the main box in the root component made it harder to organize the project as I added additional features. Now I can move on to building the actual model, starting with a sketch on the XY plane for the bottom panel, and I'll press R on the keyboard and draw a rectangle with the dimensions set to width and length. Then I'll press E and select a rectangle to extrude the bottom panel using the thickness as the distance. I can then expand the main box component along with the underlined bodies and sketches and rename the body and sketch to keep things organized. And I'll use a similar naming convention for the additional bodies and sketches I'm going to create. Next, I want to create the fingers along the front edge of the bottom panel, so I will draw a new sketch on that edge and press X on the keyboard to turn on construction line mode. Then I'll press L to draw a line at the midpoint of the plane from edge to edge, and another line at a 90-degree perpendicular angle to the first. To make it easier, I can find the midpoint on my first line and then move the mouse over, and we can see the blue dashed line that shows I'm staying aligned to that midpoint. If I draw the line now, it will automatically add the 90-degree constraint for me. With both lines drawn, I'll add the midpoint constraint so that those two lines are always centered around each other, and then I can turn off construction line mode. Next, I need to draw a solid rectangle from edge to edge, then add a coincident constraint between the endpoint of my reference line and the far edge of the rectangle. I can then press D on the keyboard and add a dimension constraint to the rectangle with a value of hfingerw, and press D again to add a dimension constraint to my reference line, which will be L'. Again, I press E on the keyboard to extrude the first notch in the panel and use negative thickness as the distance. I can rotate the view here a bit just to make sure that I'm getting the results I want. Once I confirm that I'm getting the results I want and the cut is going in the right direction, I click on OK and I have my first notch. Next, I need to replicate that notch along the edge. I'll use the rectangular pattern from the Create menu and make sure that the pattern type is set to feature. I'll select the feature from the timeline that I just created for the notch that was cut. I'll select the direction using the red axis line coming from the origin point, leave the distance type to extent, set the quantity to L notches, and the distance to negative L notch minus L fingerw. Since I already have one finger cut along the edge, I need to reduce the distance by the width of that finger. Now I'm cutting all of these notches in the same body, so one thing I've just recently learned is I can change this compute option to identical, which will perform the operation more quickly than the default value of adjust. This isn't a big deal for this model right now, but it can make a difference in more complex models. If you happen to use this on another model and the pattern that you're trying to duplicate doesn't give you the results that you want, adjust will most likely give you the correct results, but it will be much slower than the other two options. In previous videos, I only cut the notches along one side, and then I created the front panel, duplicated that panel, and then used the resulting back panel to cut the notches on the other side. I was essentially making the model more complex than it needed to be, and I've found scenarios where that technique will break. So really the right option here is to use the second direction of the rectangular pattern, set the quantity to 2, and the distance to width minus thickness, and that will duplicate the notches along both the front and the back edge of the bottom panel. With the front and back notches cut, I perform the same set of steps to cut the notches along the left and right sides of the panel. This time I use hfingerw as the dimension for the rectangle and W notch L for the length of the reference line. Then, when creating the rectangular pattern for the left side notches, I use W notches for the quantity and W notch L minus W finger W for the distance. When creating the rectangular pattern to duplicate the notches over to the right side, I use the distance of length minus thickness. Now I create a new sketch on the XZ plane and draw a rectangle starting from the origin point and use the dimensions of height and length to draw my front panel. Instead of trying to align the sketch to the edge of the bottom panel, which projects a point into my sketch, I'd rather rely on the single origin point that I know is not going to move or go away, and then use my dimension values to drive the size of this panel. When I was relying on projected points from the bottom panel, I again found cases where it would break because the projected point might not be recognized by Fusion360 as the number of fingers change on that front face. So this removes that point of potential breakage. Now with the front panel drawn, I need to use the combine operation from the modify menu, set the front panel as the target and the bottom panel as the tool, set the operation to cut, and enable the keep tools option. That will cut the fingers along the bottom of the front panel. Now I need to draw a sketch for the left side of fingers of that front panel. In previous videos, I drew the sketch on the left face of the front panel, but this time I'm going to draw the sketch on the front face. This will give me some additional flexibility in the future when I add dividers to the box and help me avoid any unnecessary complexity in my model. I'll turn on construction line mode and draw my midpoint line from the left-hand side of the face and set the distance value to thickness. I'll make sure that a perpendicular constraint exists to keep this line at a 90-degree angle from the edge. Next, I'll draw my reference line again at a 90-degree angle to the midpoint line and add the midpoint constraint to make sure these lines are centered around each other. I'll turn off construction line mode before drawing the rectangle for my notch and adding the coincident constraint between the endpoint of the reference line and the far edge of the rectangle. I'll add the dimension constraint for the notch with hfingerw as the distance value and another dimension constraint on the reference line using hnotchl as the distance value. Once again, I'll extrude the cut through the panel for my first notch and then add the rectangular pattern to duplicate that notch along the height axis. For this pattern, I will use h notches for the quantity and hnotchl minus hfingerw for the distance. I'll use the second direction of the rectangular pattern to duplicate the notches over to the right-hand side of the panel using length minus thickness as the distance value. Now I'm going to duplicate the front panel to the back, and instead of using an extrude operation to copy the profile from the front panel, I am going to use a rectangular pattern again to copy the entire body. What I realized in my previous model is by using the extrude operation, it does work, and it works well for just copying one body to another, but because I want this body to be reused, or I want this box to be reusable, and the parameters might change and I might add features to it, using the extrude operation doesn't account for the fact that the profile of the front panel can change, so certain features that you might add to the front panel will not automatically be copied to the back. And it can easily be fixed, but you can avoid it altogether by copying the body instead of the profile. To do that, I'll use the rectangular pattern again, but this time I'll change the pattern type to body, select the direction from the origin point, use a quantity of 2 and a distance of width minus thickness. For this pattern, since we're copying an entire body, there is no compute type option. Now I just need to draw another sketch on the YZ plane with a rectangle anchored to the origin point and the dimensions set to height and width. I then extrude that left panel body with thickness as the distance and combine the left panel with the back, bottom, and front panels to cut the fingers. Finally, I create another rectangular pattern with a pattern type of body, select the left panel, the red line from the origin point for the direction, enter a quantity of 2 and a distance of length minus thickness. I now have my completed box with all of the fingers cut along each panel, and I have reduced the number of operations that I've used to create the box. With the model complete, I'll switch over to the CAM workspace and create a setup for each of the 6 different orientations that I might need to use to cut these panels on the laser in the future. Then for the 5 panels that currently exist in the model, I will create the corresponding 2D profile laser cuts. With that done, I now have a more robust version of my box that will be less prone to break, and I have my default CAM operations defined so that they'll already exist when I import this or copy this into a new model. Now, with this model, I can still get to the point where fingers can get extremely small and they might not be realistically usable, but unlike my previous models, this box will still work for extremely small sizes. As you can see, with this model of the box, it's not drastically different in appearance from my other models, and it is a little bit of a compromise in the finger sizes that you may use in the model, but I found that this actually makes it a little bit easier because I don't have to manually guess at what I want the finger sizes to be or guess at the number of fingers that I want along a box. So I think it's a good compromise, and it also, again, fixes some problems with those other models. I hope you found this useful. Please leave any feedback in the comments below, and I look forward to seeing you in the next video.